Welcome to WIN, Small Scale and Local Systems, ESCI 211. All right, part one. So after viewing this online lecture, you should have a better understanding of what does the wind transport, mixing of the atmosphere, and the size and lifetimes of wind patterns. And the four sizes that we'll be talking about is microscale, mesoscale, synoptic scale, and global scale. All right, so let's see. So what does the wind transport? Let's see. It transports heat, moisture, dust, insects, bacteria, pollen, just about anything that can be carried in the wind. Does the wind do anything to these elements? It mixes them quite well. And what causes the mixing we're looking for? These are called eddies. So basically, eddies are spinning parcels of air that come in all sizes. Where can we see these eddies? We can see them in lots of places. So here's an eddy right there, I believe from a smoke trail. The wind is moving. So the wind's going this way, and you get these eddies, or these spinning parcels here. You got another spinning parcel there, a spinning parcel there, and a spinning parcel there. All right, so now here's a graph that shows the lifespan, the time something can exist, and the space it takes up this way. So basically we can have small turbulent eddies are considered a microscale, and they only last a few seconds to minutes. You can have mesoscales, and they're much larger. So the mesoscales are more like thunderstorms, tornadoes, and water spouts. The synoptic scales are what are called the sea breezes, the mountain breezes, or the Chinook winds, or hurricane or tropical storms. And then the global scales are the high and low pressure systems or weather fronts, or the long waves in the westerlies. And the bigger they get, the longer they last. So let's review the sizes. So you have the microscale, and they sizes are around 2 meters or smaller. Time scales are seconds to minutes, and these create small turbulent eddies. Examples would be smoke from a smokestack, or trash blowing in the wind, or dust devils, or even water spouts. The next size is the mesoscale, and that's about 20 kilometers. Could be larger or smaller in size, but less than 20,000 kilometers. And this time scale is minutes to hours. So thunderstorms would be those kind of eddies, or tornadoes, or larger dust devils, or water spouts. The next size, the mesoscale, continues here, and the time scales are hours to days. So you can have land breezes and sea breezes, mountain and valley breezes, Chinook winds, or Santa Ana winds. These Santa Ana winds, which we hear a lot in the news, that hit LA and the California area, and they can create these huge firestorms that we hear happening out in California. All right, so synoptic scale, sizes of about 2,000 kilometers, scales lasting days to weeks. Examples of these storms are hurricanes, tropical storms, highs and lows, and weather fronts. And the picture here is is a picture from a freighter on the Atlantic Ocean as it was sailing in to a hurricane. that was sent to me by a former student who took this class. Last size is the planetary and global scales, and they're about sizes of around 5,000 kilometers. Time scales are days to weeks, even longer than that. Examples are the global wind patterns, long waves in the westerlies. Sometimes the synoptic scale is also called the planetary scale, or these can be combined into the macro scale. All right, so I hope you have a better understanding of what winds transport, better understanding of mixing in the atmospheres, these things called eddies, and the sizes and lifetimes of these wind patterns. Now, the four scales that we talked about are the microscale, the mesoscale, the synoptic scale, and the global scale. And it would probably be a good idea to know one of a particular example of either of these classes of scale size and times. And that's all I have for you in part 1. See you in part 2.